Hi everyone. I'll I'll give you a demo on the project that we are working on. So objective the objective of the project is to create a working web application, both front end, back end, along with a database. So then here to deploy an application based in local and cloud, we are using Docker to containerize both our front end, back end, and our database. We are using Terraforms to create VMs and deploy to cloud. Here we are using GCP as the cloud service. And we are also using Python load testing using a Python framework called as Locust. Then the last thing we are going to do is to compare the performance of local with respect to cloud in terms of scalability. So we are using autoscale feature that scales the instance VM set to a set number when the CPU utilization is more than 80%. That's how we have configured it. Let me walk through to the code. Starting off, we have a front-end application. This is written in React, and we have Dockerized it. I'll quickly walk through the Docker. So here you have the from a node instance, we are copying everything that is inside this directory, running npm install, then exposing 8000. This is the port where the front-end application would be running. Then we are also running npm run build command, which will build the minified JavaScript based that is generated using Webpack. Then at the very end, we are running the command called as node space server.js. This will run the front end. Backend we have backend we are building using Express and JavaScript, Node.js, JavaScript. So we have three different routes in our backend application. We have one route for adding a student. So we're building an application that a student, a UI where you can add a student, add a student and list all the students. And we have one API for adding student and one API for listing students, and third API is for a complex mathematical calculation. It does a random vector multiplication between a vector of size 500 into 500 that just so that we increase the CPU utilization. This is a backend, and we have also Dockerized the backend application. So if you can look, we from the Node.js base image, we are moving into a working directory, copy everything. These are the environment variables that is required for the backend. So that is the Postgres username and password, and Postgres endpoint, and then the backend endpoint and the port it should be running on. Then we are doing an npmi exposing the backend port, that is 5001, and we are doing command node.app.js. So an Express application is running on the backend. So here for the database, we are using Postgres. From the base image of Postgres, we are passing two environment variables: the Postgres username and password, and the DB name. And we are then initializing the entry point for the Docker. We are passing an SQL query. This SQL query basically will create a table with the given primary key and the columns that is specified. This is the intent of it. And we are so we have three different Docker images. So we wanted to deploy these three together. So in order to make this process, we wrote a Docker Compose file. So Docker Compose file has three services. If you can look, there is the Postgres. So we give them, it says to build the Docker file, you have to go to the path database / and you'll find a Docker base. We are naming the container and giving the environment variables, and also attaching it to a network. Backend, similarly, we are specifying where you want to sync, passing the environment variables. Also, we are attaching the dependent is it depending on the if the Postgres API Postgres service fails, this will not actually spawn up. It will throw an error. And the backend also, we are exposing the port 5000. Here is the internal plot, and here is the external plot, and second is the internal plot port, and it is exposed. And we also creating a network called a student registry network, which attaches both Postgres and the backend. So if I go here, I have already running it. I'll just close it. So I'm doing the command called as docker compose up build. So this will build all the Docker files and also bring it up based on the Docker specific docker compose.yaml specification. And here, if you look, the frontend is running on port 8000 and backend is running on 5000. Let's go to port 8000. So this is a project that we have built. It's basically a React application with that has one CRUD API. Here I'm going to create a new entry, a student. My age is 27. I'm putting in a class as 1. So now a student is successfully added in the DB. And there is a, if you refresh it also, it is pulled this data from the DB, which is running as Docker Compose. That we have so far come across. Now let's how to load test on the API. So for load test, we are using a Python library called as Locust. So let me just pull the code for it. Locust, we import the Locust. Then what else? We call each API. This is a list student API, and another is add student API, and third is matrix multiply. This is basically a complicated math, so it will take some time to return a response. So this we have created using a virtual environment. So let me cd into API testing. Then let me create a virtual environment. Then let me cd into bin, and I'm activating the virtual environment. Then I'm returning back to the Python file. Then I'm installing Locust. So Locust is a Python framework that is used for load testing on APIs. So then I am going to do a Locust Python file. This will run an interface on this port. So this is what the Locust. So I can say at a time concurrent 10 users are coming. Ramp up the users at the rate of 10 per second, or let's put it as 1 itself. And this is our backend endpoint. Let's start hitting it. So now what happens is that the APIs are being hit. So here you can see 6 users are there. This is the current RPS. So there were 12 requests were, and there is 30 requests of student. This is completely taken random, and the multiply. And here, if you look, the median time it takes is the average time it takes is around 1 second for one API to return. The average, and this is what the average size that it returns. So you can see the current RPS is only 6.1. So our intent is that when deploying on the virtual machines, you will be able to see much higher RPS, as whenever the load increases, it will increase. So here you can also download the data. You can download the report. This will give all the with the number of failures and what is the mean average response time, everything, and the number of users, etc. Now closing the Locust. Now let me get back to the next part of the video. This is Terraforms. So Terraforms, let me just get to them. Terraforms. Terraforms, you need to install Terraforms. Then let me just cd into Terraforms. So here if you look, I can initialize. So only initialize if the one's project is running. So then there is Terraform plan, which will do a evaluation of if you made any error or not. Terraform apply will call all the GCP APIs under the hood and run it. So here our approaches, I have provided, my provider is going to be AWS, and I have added the credentials that is required on a JSON called a service and called key.json. Here is a health check API because it is a VM. I have added one more resource like that. And this is a template that I am keeping. This is a Google Compute Instance template. I am running it on 4 GB machine. So N1 standard one is I'm attaching a disk. This is a standard disk with a source image of Ubuntu with 2004 LTS. I'm attaching a network interface, and I'm attaching as a default. And here I am adding a metascript. Metascript is something that will run on when a VM actually boots up. So here it basically does it updates, it installs docker and docker compose and git. Then it git clones this particular repo itself. This is a public repo, and then it navigates into it and do a sudo docker compose up. Then I'm attaching another resource called as group manager. This basically would is kind of this is equivalent to something called as a if you go instance group. You can create an instance group in GCP. This is kind of like an autoscale solution for in Google GCP. Then I am attaching ports to it, all the ports that I am exposing. I'm also adding a auto heal policy as well. Then I'm attaching an autoscaler into it. Here is where I'm at. If you look, this is the group manager, is basically the group instance or something called as instance group. I am adding an autoscaler resource to it. I'm telling that it is minimum number of replicas is 5, minimum is 1 and maximum is 5, and the target is CPU utilization of 80%. Then I am attaching a firewall. So intent of it is because I want to expose these port 80, 8000 and 5001, the backend and the front end. And I am allowing traffic from all the ranges. That's why it's source range of 0/0. Then this is basically just saying that I am outputting it so that it looks elegant. So let me do a Terraform plan. If you do Terraform plan, this will just validate the Terraforms, and it will update in if. Okay, so here if you look, plan is 0, add is 1 to change, and 0 to destroy. So I've already done it. It takes a while for it to actually deploy, because it needs to install the Docker everything. Okay, starting now we are going to actually check verifying that the port is open. So we are going to run the load test on the IP of the ephemeral IP that GCP provides. We are going to hit on this IP. Okay, so let's start 0. Okay, now we can actually see the request per second actually increasing. That is it is now 13 requests per second, and the RPs is coming around 1.89. So here I'm running it on an 8 GB machine, 8 GB 4-core machine. This is why you see the RP is relatively lower, and I do not have the enough quota to get a 32 GB or even bigger machine. So while on the other hand, my personal laptop is actually quite beefy. This is why we were able to get 6 RPS. So even in the VM, it is actually it's because of the I do not have the quota to increase beyond that. That's all.